Great, so let's start. Welcome everyone to the next edition of Miton AI Times. I'm excited to see you all here, both people who are present physically and people who joined online. Today will be a little bit different format. We have done it in the past, but it doesn't happen that often. We will have a panel discussion on the topic of future of juniors as AI takes over coding. We're going to talk more about this later. But before that, we will also introduce some topics, just for context. First, we will talk about the competition that GLAMI held jointly with FIT this semester with juniors. And then we will also present results of the survey that we sent to all of you some weeks, months ago, so that we all have the information ready for the discussion. Right, in case we haven't met, my name is Tonda Hoskovec, and feel free to approach me after the event. There will be space for general networking here. There are drinks in the back. I'm the main organizer of Miton AI Times. And if I go back to the organization, if you have any questions during the panel discussion, please wait for the end. At that point, there will be time and space to ask them. And also, if you are online, please stay muted and type your questions into chat. I will read them and I will ask them for you. But that's for the end of the event. So without further ado, I'm going to hand over to Čenda so that he can talk about the competition that he put together in GLAMI with FIT together.
Thank you. Hi, my name is Čeněk, and currently I'm a AI lead at GLAMI, and also simultaneously I'm studying a PhD at Faculty of Information Technologies at CTU. Today I would like to talk about the competition that we put together at FIT. The competition took place this year in a summer semester for the students of the 4th year, and the whole process of the competition was that instead of doing some semester work or term project, the students could opt in for a competition format where they would have a competition. Sorry about it. So the competition was among the students, and it was for a subject called algorithms of data mining. And the whole idea is that to take a data set that the students haven't seen before and that hadn't been published even for the broad community, so that students couldn't cheat and use other solutions. And their task was to create an algorithm competing against other students on a leaderboard that was publicly available. So let me first tell you what the competition was about. So as GLAMI, we are a fashion aggregator, and as a fashion aggregator, we often have the same product available from different shops or different providers. So the task is to group several items, several offers from different providers to the same underlying real-world product. And the problem with this data set is that it's basically a clustering problem, but we don't know how many clusters we actually want. We don't know how big the clusters are going to be, and the data are usually messy. What data were available was the images of the products, some textual description, titles, and other similar features. And the students were supposed to recognize which products, which offers belong to the same underlying products. So let's say you can see that here for the yellow sneakers, you have 3 different products, and this was the task. So as I already mentioned, we had 71 students participating in this challenge for a data set of around 1 million items. And the competition was split into two phases. In the first phase, the part was much easier because it was the idea was for the students to get familiar with the data set. So they had always 5 items, and the task was to decide if there's at least 2 items that belong to the same underlying product. So it was basically just a duplicate detection. But in the second part, they had a data set of 1 million items, and they were supposed to do the clustering into the groups of the same product. The problem is that some of the groups had just 2 items together, but some of the groups could have up to, I think, 150 items. And it's quite hard to do this right. As we gave them a data set of 1 million items, the only problem wasn't just coming up with an algorithm that can do this, but the algorithm had to be quite efficient for it to process 1 million items, because you cannot just ask every item with the other if they are actually the same product. So the challenges that they need to overcome were mostly over-merging, where if you have 2 big groups and you have one edge in between them, they can merge into a huge group, which doesn't actually make sense and makes the scoring much more difficult. During the competition, the data were split into 3 parts. The first one was train and validation, where we gave students even the labels, and they could decide how they want to split this data and use this data to train any model that they wanted. They could have asked ChatGPT, anything, like any tool that they have, they could use. Then the second part of the split was used for a public leaderboard, where students could submit their solution and see their score right away and compare their solution to solutions of other students. And the last part was a hidden test data set, where they could only submit one solution, and the results were provided after the competition finished. What was actually quite nice was that the results on the public leaderboard and hidden test split weren't the same, because some students were optimizing too much for the public leaderboard, and they didn't end up as good on the test dataset split. Last part I want to talk about was, even though every student had a unique solution, was that no matter what model they used for processing images, the visual dominance was quite apparent there. Some used clip embedding, some used specialized fashion clip embeddings. Other students used anything else, some descriptors or anything, but every time the visual dominance was quite apparent. The second part was that generating some candidates using embeddings and cosine similarity was usually the way to go. Learning some re-ranking for the best candidates with like GBM or something else could boost the precision much higher. And the last part, which could provide the significant results, also were some strict guardrails, which was just conditions, for example, limiting maximum group size. Yeah. And that's all from me. And let me give word to Filip, who will lead you to the discussion.
Thank you, Čeněk. I'd like to ask our guests to also come on the stage. So Dominik, Michal, and Adam. And before the introduction, I'd like to do like an opening statement and present the data that we've gathered. So hey everyone, my name is Filip. I also used to be an engineer before becoming an investor. And today's topic is AI and its effects on junior developers. There's a famous study that came out last November, where Stanford economists got access to payroll records of millions of American workers. And they published a study that caught a lot of attention. They found that since generative AI came, employment of people aged 22 to 25 in AI-exposed jobs dropped 16%, while for senior people in the same kind of jobs, there was no change. And from from 2024, it hasn't stopped. It's still growing and about half a percent per month. And so I was thinking, if you extrapolate this trend, is it going to be that there's just the C-level and handful of senior people with army of agents doing all the work, or is it still that hiring junior engineers is a good idea? And despite what we're seeing in the American data. And so, there was no public data from the Czech market, so we decided to do a survey ourselves. And we will share all the results, I think, next week. But we can present just a few results. One of them is 80% of committed code is AI assisted already. By the way, this survey comes from like 47 respondents in this group. Maybe we can go to next slide. And what we found is that AI today mostly helps with junior work. 73% junior tasks are AI affected, while only 32% of senior tasks and architecture-related topics are affected. Next slide. And when we asked how do junior developers or developers in general expect their work to shift within 2 years, the most frequent answer was they will focus more on product and business rather than just pure engineering. Second answer was more focus on architecture and design. And third was they will focus more on AI orchestration rather than just coding by hand. So that's it for the opening note. And I'd like to ask our guests to introduce themselves first.
Okay, I'll start. Hello, my name is Dominik Moštěk. I'm CTO at crypto exchange Coinmate.io. I was previously engineering lead in Atacama, and before that I was for 15 years software engineer in various positions.
Hi everyone. My name is Michal. I'm a CTO at Rohlík Group. I've been with Rohlík for 3 years. Previously, I was head of data science for Bauer Media Group, and before that, I was leading the EY's advanced analytics team. And my background is machine learning engineer.
Hello, I'm Adam Štýbr. I'm studying at Czech Technical University, and I'm here as a winner of the previously mentioned competition. And I have a small part-time job in Škoda Auto as a developer.
Thank you. So what I like about this setup is we have 2 CTOs. It's as senior as you can get, and one student who's about to be junior engineer next year after finish school.
I'm intern. That's more accurate.
All right. So this is you're the main topic of this conversation. Wow. And
no pressure.
So maybe I have a simple question to start that I'll ask Dominik and Michal. Did you hire more or fewer junior engineers this year versus last year, like in a comparable time frame? Does the reality in your company suggest what we found in the Stanford data or contradict it?
Proportionally to my previous job, because we are a much smaller company, I think we hired probably the same amount of juniors, but we are restricted by the budget. If that wouldn't be the reality, I would hire much more, to be honest. So I will get to the reason later on.
So I think we hired less overall, right, on all levels, not just juniors, but I think even proportionally we hired a bit less juniors. But I think a good discussion to have would be what constitutes a junior, right? Because even if you have just a few years of experience right out of school, you can build 3 different startups, right? So I think it's a question of what is junior.
Yeah, we'll get into that. And I'd like to ask Adam, so you write code for school already for, you want this project. How much of the code is written by AI actually today? Is it 80%? Is it more?
I don't know in terms of amount of code, but I started with my ideas, and I used AI tools to consult them and research them. And then when I had during development some ideas to test, then I used AI tools to test those ideas quicker. But I decided to start with simple model and iterate on it. So the programming wasn't really a huge bottleneck. It was more about preparing which direction to take and which to avoid.
And Adam, you study computer science. You're in the 4th year or 1st year of masters. Are you and your classmates worried about being able to find a job next year after finishing?
I don't know about what are the exact opinion of others, but I'm not that worried. I think AI will get better over time. It can already now do a lot of things, but I think it can still fail, and it's still best when someone who understands the underlying task and the code base the agent is working on. I think programmers will still be necessary.
Thank you. And so the most important question that I have, so maybe you can start with Dominik. What does a junior engineer what does the role look like today compared to 3 years ago in your companies?
I think main difference is that before we hired mainly programmers, junior programmers. Now we hire junior product developers, or how to call it. Our most successful junior is actually a mathematician. He does a lot of coding, of course. He designed all part of one of the products we use. He did 100% of the coding with AI. He haven't touched the code himself at all. So that's the main difference. Before we were looking for talented programmers. Now we look for talents only.
I would probably second that, but also what we are currently looking for mainly is, I would call it agency. So being able to take a problem and solve it, and let's say have the internal drive to solve maybe even things that were not really, assigned to you, but you solve them as a problem. So that self-drive, that's getting more and more important, right? And we've shifted towards building rather systems for agents to work well in, right? So it's not about coding anymore. Large part of the job is still a review and, let's say, making a judgment whether this can go to production or not. But the key part is, okay, so how do we build a system from the repo setup to deployment to pipelines, so that you can just release the agents in there and they can ship to production. So that's currently the skill set that's most sought after, where I am.
Could you also comment on So the skill set that you'd like to see is, it doesn't have to be an engineer by training, but like a mathematician who's a system thinker or someone who has agency. Would you also comment on how the like average day of your, let's say, newest junior engineer looks like their first month, if you know?
So I think it's not that much different than before, right? I mean, the structure changed, but the key parts where you need to, you'll come in the morning, you'll need to understand the problems that you are about to solve, right? So you go through the requirements, through the bugs that were found out, through any incidents if they happened, and then you work through them less by writing the code yourself, but directing the agents to the tasks which they can handle right away. Then maybe picking one task yourself that you can is more difficult, larger feature that you'll spend some more time of your day on, and then you'll typically coordinate a few agents and walk them through to fixing the thing, review it, and put it into production. But beforehand, you parallelized a lot less. Right now, you can just run 4 or 5, even more agents. I think the average where we are is about a few agents, handful of agents. Some of them you just let run, and one task you take as your main one. That's the most complex one. So I think what changed a lot is the proportion that you spend on writing code. So 80% you just review, right? And most of the time of our engineers is on review now currently and approving. And then you just see the bottlenecks where agents get stuck, and you improve the system as such. So you should always make it better for the next run, right? So that's more seamless. So I think that's the typical day.
Yeah, I will second that. And Michal already told that now it's about self-driving the proactivity, and I think that changed a lot since before there was the adoption of the junior was more mechanical. Like he had a lot of time to spend on coding, someone helping him. It was really straightforward. Just contribute to this repo. Here's this old bug with low priority. Just work on it for a week or whatever time. But nowadays, I don't know how about you, but I have never had so much work as now. AI promised that it will steal our work. It didn't. I have so much work that never before. So I don't have time to be present with the junior. So he spends most of the time like being proactive, finding the information, how to contribute, what to do, how to improve. So that's the main difference, I would say.
Maybe I would add, 2 hours ago, I had a discussion with our engineering managers and with our tech leads. And the question I posed was, okay, so we've doubled our output recently. So, what's needed to double it again, right? And one of the things, besides some technical blockers that we need to just fix, the second most important thing was talent. And in the talent part, it was mainly ability to multitask. And because we have engineers exactly in the same, we have cells, right? So a few people that solve a particular problem. An engineer exactly, 2 engineers exactly in the same cell, similar tasks, the same tools, same repos. One has triple the output of the other, right? So what's the difference? And one of the key ones that were voiced by our tech team was, okay, the ability to multitask, to just ability to have several agents solving tasks while you do your main one, and jump from thing to thing without actually going crazy. That's the key point now.
Did it also have an effect on the team structure? Like we've seen in the survey that engineers expect to do more of the product work. I see also like the lines between design, product, and engineering are sometimes getting more blurry. Do you see that in your companies already, or do you still think there's benefits of focusing on just one thing but doing it maybe better, faster with AI?
I must say I recently shifted my opinion on that. I was never a very big fan of full stack engineers. I liked like being expert in one technology or field. But with AI, I think we are going to rethink that and be more full stack, because when I see AI is really good at is building front ends. So I think our backend guys will not be very happy about it, but we are going full stack now.
So we've been full stack for some time, and of course you will have product engineers that are more, they've been raised on front end. Someone was raised on doing back end. So of course some people will naturally gravitate towards or have some sort of background, which made them better at certain things. But we are full stack for some time. The thing I think you mentioned is, okay, doing more product work, doing more design work, and I think those are merging, right? So we want people to actually not do the handovers, right? Because the most of the time wasted in engineering is when you need to explain to someone what you want. So product will explain to design, and then design will do something and try to convey that to engineers. So the less we have these handovers, the better. And of course, we have people who are better at certain parts of that. So I think they are merging. Our product people ship, our engineers do make product decisions, but you'll still have some natural cognitive tendency to be better at some things than others, right? So I think that will stay. So even our product engineers that make product decisions will ask sometimes the product person to, okay, so what would you do there, right? What would the customer think of this?
So since the job has changed and the expectations of what it takes to be a junior engineer, in your companies has changed, I think that the hiring must have also changed. So how does the process look like? Like when I was an engineer 10 years ago, I was doing these coding assignments where I had to, by hand reverse a linked list, or I would get like a homework to come up with something over a couple of days and return it to the person hiring me. Do you still do this, or can you walk us through how does the process of hiring a junior engineer even look like today?
I always hated coding tasks. Like that was the first thing I always removed when I got into charge of any team or project. So we are not doing this anymore. Never. We are, or I'm fan of hire fast, fire fast. So most of the decision is from the feeling I have from talking with the people. Then if there is a fit, we hire you, then prove yourself for month 2, 3, and we will see. Prove yourself in the battlefield, not on some artificial task.
So in terms of hiring, we have a few rounds, right? So there is a sort of a technical discussion, not really, whiteboards, solving coding challenges, but technical discussion with your hiring manager. We have then sort of a panel where we are looking more like for a culture fit, because that's very important. And we do have sort of an assignment, right, where you are supposed to develop something, build something, and then walk through how you build it, what were the decisions that you've made, and maybe some sort of technical details of the solution. We don't have that part where you would get a real algorithmic question, right, and you would need to solve it manually. So that we don't do, but we do have a technical part of the interview or the interview rounds where you are expected to build something and understand what it does, right? So I think that part where you sort of know what the thing you build does on a detailed level, that's still important, because if something breaks, then you are expected to fix it still. That's mostly, although that not as much as before, but that's still a very human driven. If something breaks, you have still the AI helping you troubleshoot, but a lot of times it's still like a human intervention in the sense of, okay, so where most likely did it break?
Could you like maybe explain more, how does the interview even look like today? Like, it's difficult for me to imagine when you don't do coding assignments. Is it like mostly, how do you even like, or maybe how do you said agency is the most important. How do you even test that? Is there a way to predictably, like with some predictive power, test that before letting them in for 3 months and like giving them the chance to prove themselves?
So there is, right, but it's not it's not a sort of like a test that you do and you pass, you fail. It's more around through the sort of probing what they did before, how they acted in certain situation. You can infer whether that person is a self-starter, or whether that's sort of the approach of, okay, so a ticket lands somewhere and I will take it, I will read what's in it, right? So it's rather, and I think you can fairly easily tease that out during an hour-long conversation.
It's very similar. I just sit with the people in the cafe, and every interview is different. I just follow the person and check for the culture fit. If there is a fit, there is a second round with our engineers. There's no coding, whatever. It's the same. They sit with him and just ask like random questions and see the reactions, exactly how this person will react in the real situation. So it's more about the feeling from that person, from that interview, than like any hard data on CV or coding tasks. Then we will throw them in the wild and see if they haven't lied on the interview, if they really have the ownership, if the thing they just shipped has broken, if they really jump in and try to figure out what's wrong, fix it as fast as possible. So that's what we go for.
What I would mention though is that for more senior roles, or doesn't need to be senior per se, but let's say roles that are more important in the organization, we do you will work for a day with us, right? So we have sort of dry run, and during that dry run, it's fairly easy to understand how it will be working with you, right? Because you spend some time together on a real problem, real issue, and try to solve it.
A question for Adam. has the way computer science is taught at university changed after AI? And like, do you feel you are prepared for what the industry, like Rohlík and Coinmate looks for from the university?
I don't know if it changed that much, but I think before AI, if there were something difficult, something that you need to learn, you need to put effort in it. And now if you don't understand something or have even some assignment or anything, now anyone can use AI, but then it will not learn as much as if you would learn it and put the effort. But I don't know. I think the programming in any specific programming language is that big part of the study. It's more about everything around it.
Yeah, like when I studied in Brno in Masaryk University, I was doing like theoretical computer science, and in the other building there were people from VUT, which is like they could code, but they didn't understand what they're coding. But like we couldn't code, but we understood the systems and like had the math behind it. And I feel like now the system thinking and like understanding the principles, the first principles is maybe more valuable. So I think it may be that's how the curriculum shifts for all engineers now.
And then the question is, how do you test or validate that you actually understood sort of first principles thinking and the system thinking, because that's much more difficult to validate than if you just validate, okay, can you do this algorithmic challenge? And so I think that's a very interesting topic to solve in education.
That's the reason why we confront the new hires with the reality as fast as possible, because that's what you can see from their actions, not from the code, right? Because as you said, validating good code is really you can do it on the interview, but the thinking, system thinking, and so on, that's probably not possible during 2-hour interview at all.
So maybe now assume that a junior gets hired, right? And I wonder, what does it take for him or her to become good, or what are the likeliest failure modes today? And again, like, how do you think it has changed? I already mentioned it before, but
I think it's just giving up, right? Because I really do think so, right? So it's not different now than before, right? So if before it was this thing didn't compile for me, so I made lots of syntax mistakes, and I can't be bothered continuing. Then you'll not going to improve. It's the same now, right? So you'll just we just brought it, or it was brought to a higher level of abstraction, right? So now it's not, this doesn't compile, it's this did not ship, right? Or so you'll still have challenges, different ones, but I think the key thing is, okay, so did you fix that, learn from it, and continued, or did you say, okay, that's not possible, let someone else do it?
Exactly, like the coding was always the burden of our work, not the point of it. So I think getting rid of this burden, getting rid of all the nonsense discussions about indentation or if Kotlin is better than Java or whatever, this is all gone, and I'm really glad for it.
And I can recognize that someone enjoyed it, right? That's always someone enjoyed coding in, I don't know, assembly, and then someone rather used Python, right? Also something more high level. So we have different things, and that's okay. But the question is there a market for it?
Oh, is there anything you'd recommend to like the 20-year-olds who is studying computer science, who want to become great engineers, become CTOs one day? What would you be doing in their shoes? What would you focus on? Is it just, as you said, just like, build great products, don't give up? Or is there something specific you would be doing more?
So I'll be completely honest. I have no idea, right? I don't know. And I think if I asked, the same question someone 20 years ago, right, I could have gotten an advice, but I'm not sure it would be a good one, right? What I do think though is, building real things, right, and sort of trying to build something and see if it's used, if it doesn't make a difference in someone's lives, and sort of iterating on that, and not stopping doing that. That's going to be always valued, right? No matter if you know how to code or if you do it in this language or that language. So that's always going to be valued. But besides that, I honestly don't know whether you should rather focus on systems thinking, architecture, AI principles, how to train neural networks. I have no idea what's going to be in 2 years or 1 year, not to mention 5.
I think if you want to pursue like the engineering path, not to be like an startup founder or similar, like purely engineering, I would maybe step back a bit because my controversial opinion is that technically nothing has changed in IT since 1970s. It's the same thing reinvented again and again. So I would study like the core principles of software design, architecture, how scalable systems are built, but not with the language, like in principles, in patterns, and so on. I have my favorite book, Structured Design. It's from 1972, and it describes how to build systems that are scalable, decoupled, and all the nice properties we want from the software. It describes it perfectly with Fortran. Nothing has changed. We just use different languages now, but nothing has changed. So I would go deeper into the back to the roots, I would say.
I think there's about time for
maybe
Q&A.
I would ask you if it's helpful. Right? So if it's if that sort of guidance or advice is helpful, or whether there's something else that you would be looking for.
I don't know. I think with AI tools, I have to use several programming language when I need to do something machine learning related. Of course, I need to do Python. So I think it's useful to think less about the specific language and libraries and tooling. And if I would start, I would just more focus, as I said, on the software design, engineering, and I would maybe be a bit optimistic that AI will still not be always as good as a good programmer, but that's just hope. We will see how it will evolve. Before AI, I think the best way how to learn would be just write some software, and if something doesn't work, learn how to fix it. And now, when many of the basic application types can be done very efficiently with AI, focus more on the design and look at the code that the AI generated and learn from it, but focus less on the specific language and focus more on software and yeah.
Thanks.
Is there anything you would ask yourselves maybe? Yeah, it was a good format. Do you have any question for yourself before heading to the Q&A from the audience?
Nothing comes to my mind, but
Alright.
looking forward to the Q&A.
All right, let's head there.
Perfect. Thank you. Question to Adam. Yeah. Like you are saying that you are not worried for your role or for your like hiring experience, right? But it kind of you won the competition, so it kind of proves your agency and your like proactivity in it. But do you see that your classmates are also not worried, or does it like widen the gap between the proactive juniors and the like passive ones that just wanted to get the job when it was like really well paid, but they didn't see, let's say, the AI future beforehand, so they just like wanted for it, but they are still quite passive?
I don't know. I didn't talk that much with others how they feel about their future careers, if they are worried. In terms of the competition, there were one student that did use OpenClaw with Claude Opus to design the whole thing. And from what I did understand from the final presentation, it was very good at the leaderboard, but it made more and more complex model that just overfitted. So I think in this round I won, but you will see how the AI will improve. So I hope that answers the question. If I didn't forget anything.
Nice. We have one question online. I will then switch back here. So the question, I guess, in general, for anyone who wants to take it, is how can a junior grow or train to be a full stack developer today?
I'd say like experiment. I guess everyone has a ton of ideas. I wouldn't aim like too much in the future. Just try anything. Build the backend, front end. Try different communication patterns. Try to deploy it. Show it to your classmates, to your friends. Ask for feedback and iterate. Do it again and again and again. That's the only way how to learn.
Yeah, but I would agree. I don't have anything better than that. But I'm really in my head. I'm not even thinking about front end, back end, full stack anymore. I'm really not.
I would say how to become a full stack developer. First start with backend, and then to be able to finish the application, you will be forced to do some JavaScript. And for that, I like that AI can help with that. I'm not the biggest fan. So I'm more used to programming the backend. So this is where the AI can help.
And maybe it's a good question whether we will need a lot of front end soon. Like right, so agents don't need front end. I already see now people are shopping on Rohlík with their agents. So maybe we will not need much front end soon.
Thank you. Thank you for interesting discussion. You mentioned that you're looking for someone who is proactive, who has agency, who is probably looking for gaps for improvement and taking initiative, ownership, and that you can identify or suggest that person is like this during interviews, technical discussion, etc. And what do you expect from resume? From their resume, what you are looking for in resume, in CV?
For junior position, the CV was always secondary. I would say I want to see like some side projects, GitHub repo with the experiments, and that was true even before AI. I don't expect you junior to have large CV with full of experience, of course. I expect them to see a proactivity with contributing to open source, side projects, experiments, what type of things.
Yeah, plus if there is anything that's sort of really live, like a live project that a website you can visit, take a look at, and if it even has 10 visitors per month, then I think that's, again, right, for sort of the junior, I don't really like the term junior, but for let's say those positions that puts you above, and for the other ones it's around you know what different types of situations in different companies you've encountered, and because I think for future, if you have experience here from front end, here from back end, you had half a year in some DevOps team, and that's a very good mix of sort of what is expected now, at least where I'm sitting. And yeah, that sort of combination of different, let's say, experiences across, and of course, every company needs a backend engineer who can debug until the end, right? But then for that person, you need 10 people that are more rounded.
Maybe I would add that the side project doesn't have to be software related. One green flag from all CVs I have seen so far is being, for example, leader of Boy Scouts or something similar, because it shows some proactivity. It shows there's a statistical chance that the person has good leadership skills, can deal with a group of people with different opinions, can do some time management and organize an event or whatever. So.
At one point you mentioned multitasking, and I was interested in my experience, multitasking is really mentally taxing. Like, how do you prepare the environment for engineers to be able to multitask? Because in my opinion, I would be most productive if I work, for example, for four hours 2 times a day, not straight 8 hours. So is there a way, how do you think it will shift in the future, or what's your opinion about it?
So I would say the sort of the time point that you are making, 4 hours 2 times a day, that I think is everyone's personal choice, right? That's not. I don't think there's lots of companies that still have the, you clock in, you clock out. So I think that's a personal choice. That is whatever works best for you. But on the multitasking, that it is very taxing. And when I speak to engineers, that's one of the key feedbacks, right? I mean, they are working harder than before. But it's also the types. I think it's also the types of tasks that you do. So so currently, as we are automating more of the SDLC process, you will be able to parallelize more, because it will just need your attention at a very specific moment, right? And we want to get that to a point where it's really just approve. And we are getting to that point. Really, we are getting to a point where you have a ticket, agent will bring it to PR, AI reviewer will review the PR, and it will stop at a point where it will say approve. Right, so you will take a look at it, okay, approve, and then agent will monitor the deployment to prod. And we are at that point. And so essentially your attention will be spent towards that moment, and that way you can sort of really multiply the output. But then there will be tasks which will be a larger feature, something more maybe algorithmically complex, something where you need to, I don't know, decouple something for a shared database, right? So something very, very, very difficult. So you'll let those 5 agents run, and you will continue working on that task throughout the day. But it's one of the key things that we are encountering now. And when I hear feedback from engineers, it's really like this multitasking is not easy thing to do.
I had almost exactly the same question on the cognitive overload, and basically, like, if you can elaborate a little bit more, like, if the, let's say, tech lead or whatever does the PR approval on their own, or if they outsource it to maybe more junior level engineers that have only that one project, because switching between projects is a little bit harder to detect, let's say, code smells in the PR if we are switching between code bases, right? Like if you don't have everything in mind. Yeah? So is it outsourced towards the people under him, or outsourced towards agents nowadays?
So the review we are doing agentically, right? So the review is done agentically. It mostly gets it right. So there is a loop where AI reviewer will give you the issues, coding agent will fix it, another iteration, until everything is green, right? And at that point, you want a person to take a look, because exactly something could be, weird or. So but that person who takes a look, it's typically senior person, because that's probably there are two key decisions that you are making. First is what you will sort of how will you structure the task, the issue, and how you will sort of send it out to the agent. And the second key decision is, okay, do you approve it for production? But everything else should be automated. And essentially, we are moving towards when the engineers are just sort of making decisions.
Yeah, same here. We are getting rid of human reviews of the code. We shifted the review to the more left of the process, to the beginning. We brought back the ADRs or RFCs, how it is called it's called differently, the architecture decision records or requests for comments. So we actually spent the review time on reviewing, let's say, the input to the AI, not reviewing the output. That's for automation.
I have one question. How many CVs do you get like per position? Maybe if it's less than 10, then you process it like manually by some HR person. But maybe if it's more, like what's the percentage of the people that goes through like the first reviewing round and actually get to, let's say, you or some technical lead person? Or is there like a HR person that filters them first? Or is there like maybe an AI agent that filters them? That could happen. Then how, if that is the case, then how do you, what's your prompt for the AI HR person, basically?
I've never used AI to judge CV, so I don't have an experience with that.
So I use AI quite a lot to prepare for the interview, right? Because we exactly those things when you are trying to sort of understand how the person thinks and whether that's high agency, whether they are open, transparent, So there's a specific recruiting techniques to figure that out, and I'm not a recruiter, right? So I use that quite a lot together with the CV to sort of understand, okay, what's the ideal things to ask with respect to your experience in the CV. But maybe answering your question, I don't know the exact numbers, I will admit, but I think it's sort of from the first interview with a hiring manager, so with the tech lead or with engineering manager, I think about one of 5, 1 of 8 will get sort of to where we are doing the panel, and I'm involved as well. So I know approximately those numbers, but then there is also a large drop off, of course, when the recruiting team sort of screens, the initial CVs and does the first discussion.
Nice. So that was, I think, all the space we had for questions right now. So let's thank our panelists.
Thank you.
Thank you for having us.
Thank you.
It was a great discussion. Thank you. I now have a couple more announcements for organization of future events as well. Thanks. So if I come back to it, well, the first thing that I wanted to mention is that we wanted to ask you to test our new product that we put together in MitonC AI Lab. It's a project for batch inference on open source LLMs. If you have large jobs that you submit, in sequence, feel free to check out Annex SH. The main benefit, I believe, is that we are significantly cheaper than other providers. We managed to optimize the workloads quite a lot. So if you have, for example, in e-commerce categorization, you can submit images about products and ask for a category all at once. So if you're interested, definitely talk to me, please. Then I wanted to mention again that the companies that MitonC invested in are always looking for people. That's pretty relevant today. So if you want to check that out, there's the QR code. And finally, I wanted to mention that we already know the date of next MitonC AI Times. It's going to be at the beginning of September. It's going to be Pavel Pechanek talking about Purobot. What they do is they already have an agent running that they rent to medical practices, and it goes through their billing administration, and it suggests how to optimize the billing to insurance companies for them. So that's the topic of next MitonC AI Times. And with that, that's all I wanted to say. Feel free to stick around. There are links And thank you again for coming. Thank you for joining. I think the discussion was great. So thanks again to the speakers.